Good morning. Hey, I said good morning. Alright, I have 2 rules. If you see something that you like and you think is funny, please laugh. I like that. And 2, if you get lost or don't understand something, please stop and ask me. Okay? So, what I want to talk to you today about is code quality. A lot of what we're going to cover today is based on mathematics and science. Except, we don't really care about that. What we really care about is that we get close enough to the answer, that we understand. Because at the end of the day, we need to make software that works. We want to understand, but we want to just get close enough. So, a lot of what we're going to talk about today is how we measure code complexity. But why should we care about complexity? Well, it should be relatively obvious that complexity means it's hard to maintain, it's not reliable. So by making simpler software, it'll be easier to understand, easier to maintain, and hence easier to make money with, which is at the bottom line awesome, right? So, complexity and quality are strongly related. Now, one thing I'd like to note is everything we're going to talk about today are heuristics. They're not exact. They're going to be indicators. The exact is what winds up in code review and what winds up when you're maintaining and fixing bugs. So the only valid measurement of code quality is what the WTFs per second. So, let's introduce a couple basic metrics. The first one I'd like to talk about is called cyclomatic complexity. It's relatively simple. It's the number of decision points in a routine. Now, when I say routine, I'm talking about either a function or a method on an object. Either one, it works both ways. So what does decision points mean? Well, let's take this example. Simple function. We've got 3 if statements, or an if, an else if, and another if. The function entrance counts as a decision point, and so do each one of the ifs. Every unique branch point counts. So our cyclomatic complexity here is 4. Simple, right? It does make sense, it does add up. For when we look at a single method, when we have between 1 and 4 decision points, so that's between 0 and 3 if statements, we can say that that's a low complexity method. When we have 11 or more, that's high complexity, right? So that's a single method. What happens when we look at an entire code base? Or what happens when we look at a section of the code base? Well, we can average it 2 ways. The first interesting way to average it is per method. So you take the total number of methods, the total cyclomatic complexity, divide one by the other. Yes? No, that does not affect complexity. We're only looking at the body of the function that we're dealing with. So, exactly. Yep. And if you didn't hear that, if you take one complex function and split it into 2 simpler functions, that counts as 2 simpler functions. So that's one way, actually, that we can reduce the complexity of the code base. Reduce the overall complexity. So when we look at the average per method, 1 to 2, so that means the average code base of a simple, the average complexity of a simple code base will have 0 or 1 if statements per method. But this is abstract. Let's look at some real code, and let's look at some real packages. Now, if you notice, Laravel down here is the simplest on this metric. On average, 1.79. What that means is the average method has 0.79 if statements. Pretty wide. And WordPress is all the way up here at the top, 6.23, or 6.28. That's very highly complex. That looks like a problem. But there's also one other thing I'd like you to know. Look at Drupal 7 is right up here at 3.02, which is moderately complex, but it's also one of the highest out of this list. Now I'm pointing this out because there's a second way of looking at average complexity in a code base, and that's per line of code. So you take that cyclomatic complexity number, you divide by the number of lines of non-comment code, and you get a percentage. 1% to 5% is low complexity, and 15% or more is high complexity. So note that this basically means that number is the percentage chance that any random line of code is a branch statement. Now, when we run by this metric, all of a sudden Drupal 7 drops from being the second worst on the list to the best on the list. Symfony scooches ahead of Laravel, and WordPress is still by far the worst. I sense a trend. So, right now we're not really sure whether this is good. We're starting to paint a picture, we're starting to get some insights, but we don't really know enough to really say whether this is meaningful or not. So let's introduce a second metric. Let's talk about end-path complexity. It's really simple. It's the number of unique execution paths through a routine. So if we take our old example, we can bypass all of the ifs and go straight from the start to the return. We can go only into the first if statement. We can go only into the else if. Or we can go into the first and the second if. We have end path of 4. We have 4 unique paths through this method. Notice that that's the same as the cyclomatic complexity. In this specific case, that's true. Generally, that is not true. And to demonstrate that, let's look at another function. This one's very simple. We have 3 if statements, the function takes 3 parameters, and we have 3 different if statements to execute. Same cyclomatic complexity. Really, really simple code. The end path complexity here, though, if we go through and count the number of possible permutations that this function can execute, we wind up with 8. So in general, the end path complexity is 2 raised to the cyclomatic complexity minus 1. That's the upper limit. It can be less, as we saw before, but the upper limit is 2 to the cyclomatic complexity minus 1. So what does that mean? Well, we can have these same numbers, and if we look at the previous, the cyclomatic complexity numbers, these are basically derived from that. So what is new? What does this bring to the table? Why is this a separate metric? What does this mean? Well, as it turns out, end-path complexity has a very, very special property. Because it defines the number of ways to execute a function, it's also the number of tests that you would need to completely test that function. And this turns out to be really special and really interesting and give us a lot of insights. So let's actually look at some code. Let's look at some Drupal code and some other open source code and try to get an idea of whether some of this code is good or not. So the first one I'd like to take is a piece of code from Drupal 7. This is production code, entity_load. You have a single if statement and a return. Really simple code, right? Cyclomatic complexity is 2, which if you remember is very low. And end-path complexity is 2. This is good code, this is awesome code, this is winning. Unfortunately, Drupal also has some not winning code. There's a function called Drupal HTTP request. And let me show you the code. So it's a big file, right? Big file. Big. It's like 80 lines, 100 lines, give or take. Cyclomatic complexity of 41. End-path, which is very high complex. Okay, nothing new there. End-path complexity of 25 billion. So 25 billion tests. Yeah. I want to put this into perspective. Let's imagine that we used one 80-character line of code for every single one of those tests. We'd require about 2 terabytes just to store the tests for this one method, for this one function. 412 DVDs, or 670,000 Drupal installations. Just to test one 80-line code, 80-line function. That's not the worst one, though. A Drupal module, known as the date module, has a function called date_repeat_or rule_process. I have no idea what this does. I've talked to people. I've talked to the author of this, and they don't know what it does. That should give you a hint as to what's coming next. It's on the neighborhood of 500 lines of code. Cyclomatic complexity of 81. Anyone, quick in your head, can you do 2 to the 80th? Now, this is a big number. This is a very big number. And as humans, we suck at big numbers. You know, looking at relative scales, we really, really suck. So let's try to put this in a better perspective. It's 336 trillion times the total data volume that existed in 2009. That's every single hard drive in the world in 2009. You would need 336 trillion times that amount. But you know what though? I don't think that quite visualizes it well enough. So I'd like to invent a new unit of measure for this talk. Everybody knows what this is? A micro SD card? A 64 gigabyte micro SD card is the current data density record. It's about 38 gigabits, or 38 gigabytes per centimeter cube, per cubic centimeter. So to put that in perspective, imagine we stack these up, one next to the other, forgetting how we connect the electronics, and just stack them up into a 1 meter by 1 meter cube. That'd be a lot of data, right? In fact, it's about 38 petabytes of data per meter cubed, which is about 1.5 megaupload.com, that site that was shut down. That we're talking a ridiculously large amount of data. Now imagine we take that 1 meter by 1 meter cube and stack it to 1 kilometer by 1 kilometer cube. We'd be about 38 yottabytes per kilometer, per cubic kilometer, which is unfathomably big. It's just massive. Well, we need to stack those cubes up to equal the volume of a Greenland ice cap to hold the tests. So I introduce to you the unit of measure, 1 Greenland ice cap worth of data. We can go better. PHPBD. Fantastic piece of software. No one's ever used it, right? Everyone uses it. Everyone's used it at one point in their life, if not from an administrator side, from a user side. It has this function, compose_PM. Cyclomatic complexity of 330. 2 to the 330th, anyone? No? Yeah, 84 digits, I believe, in that number. Because sending private messages is fundamentally hard, right? So at the absolute possible information theoretical density, you'd require about 1 billion solar mass black holes. Or if you remember that micro SD kilometer cube, if we stacked them up and we filled the Milky Way volume with those cubes, we would need 15 million Milky Ways to store the test for that. So, yeah, I think I made my point here. Complexity is difficult, and a 1,000-line function to write private messages is probably not a good idea. So, let's move on. Let's talk about CRAP. It's a real thing, I promise you. Change risk analysis predictions. It's really, really simple. It's cyclomatic complexity plus cyclomatic complexity squared times 1 minus code coverage cubed. Everyone understand that? Don't worry about it. Think about it like this. CRAP relates complexity with test coverage. So we take cyclomatic complexity, and we take our unit test coverage, and we put the two of them together into one number. Increasing our test coverage will lower our CRAP index. Decreasing our complexity will also lower our CRAP index. So, a low complexity method with no tests is good. I just said that something with no tests is good. That should be a shock, but okay. A low complexity test with good tests is great. That's what we want. A moderate complexity method with good tests is good. That's okay. We're fine with that. But a moderate complexity method with no tests is crap. So if it's highly complex, it's crap off the bat, and you can't fix it. But tests are a way to ensure against moderate complexity. So we wind up with this scale. Less than 5 is great code. 5 to 15 is acceptable. 15 to 30 is you're starting to push the border, and 30 plus is just plain crappy code. So, what do we do with these numbers? We've got these 3 basic metrics. How do we apply them? Well, as it turns out, there's this country. And I believe you're all familiar with this country. Anyone here not familiar? You want me to go into my spiel? So there's this country called Germany. They're known for certain things like beer and automobiles, but specifically engineering and engineering quality. Specifically, they like to test all the things. As a quick quiz, there's only 2 PHP quality assurance tools that are not made by Germans, or were not originally made by Germans. Does anybody know what they are? Yes?
Code sniffer?
Code sniffer? Anyone gets the other one? And this one's a relatively recent addition to the major category. BHAT. Code sniffer and BHAT are the only 2 significant quality tools that were not originally built by Germans. Now, when we say originally built by Germans, there's basically 2 categories. There's everybody else, and then there's this man. Sebastian Merton. Now, the last time I gave this talk, I really pimped him quite hard and said, you know, this man, we owe this man a lot in terms of PHP quality and understanding and improving it and testing, and we still do. But there's a special reason I'd like to mention him, and I'm going to come back to it because it fits in a little bit later, and there's a really interesting story related to this. So, he's done interesting tools like PHP Unit, DB Unit, PHP LOC, CPD, yada, yada, yada. This is a very, very, very short list. He's done a lot more than this, and he continues to do a lot more than this. If you don't know this man, go look it up, go look at what he does. Good stuff. So, the first tool I'd like to talk about is PHP LOC, PHP Lines of Code, by Sebastian, of course. So it's a command line tool, and it summarizes an entire code base. So I find this tool is completely invaluable, meaning it's absolutely necessary when you first get a new project. When I first get a new piece of code at work that I've never looked at before and I know nothing about, the very first step I do is I go into that code base and I run PHP LOC. Because it tells me things about it. So let's run it on Drupal 7 and kind of look through what it tells us. Well, the first 2 things it tells us are number of directories and number of files. Okay, interesting metadata. We're starting to get a sense of the scale of this project. Not particularly useful, but interesting. Gives us the number of lines of code, so 63,000 lines of code. Okay, wow, that's moderate scale. Not huge, but not small either. But right now we have cyclomatic complexity per lines of code. So right here, the second number, the 4th number in that we get, we now have an idea of the complexity of the code base that we're dealing with. This is cool, we're starting to get a picture. Then we can go through a number of comment lines of code and non-comment lines of code, so we can see, hey, there's roughly about 30% of this code base is comments. That might be a good thing, that might be a bad thing, but we're starting to paint a picture. Then we can go on, the next part of that information tells us about the namespaces that are used, the number of interfaces, number of traits and classes, tells us the relationship between abstract classes and concrete classes, and it also gives us this really interesting thing here, the average class length. How many lines of code are in each class? Again, not particularly valuable when you're diving deep into the code, but when you're initially looking and you want to get a sense of what you're getting into with the project, pretty interesting. And then we can get down to the method level and look at, well, how many static methods are we dealing with? What visibility? Okay, 60% of all methods are public. 178 are non-public. Okay. And then we can get the average method length of 17. What this is doing here is it's letting us know a little bit about the architecture. Is this mostly functions? Is it mostly classes? Are the classes mostly static or are they mostly non-static? By looking at this, it takes about 4 seconds to run on a decent-sized code base. We can get immediately a really interesting snapshot and an idea of what we're getting into before we even open a single file. This is powerful. This is really powerful. But once you're into the project, it starts to become a little bit less useful, right? Because once you start knowing the project and once you start understanding these files, why do you need this? Well, there's another tool for that, pdepend. This one was built also by a German, not by Sebastian. It's like PHP LOC, meaning it gives us the same information, but it gives it on a per method level. So where PHP LOC gives us one snapshot of the whole application, p2pen will generate an XML file, which breaks out on a per method basis every single one of those metrics. So we can now process and run through and track complex methods and say, hey, this particular method today is really complex. Tomorrow, did it get better? So now we can track with PHP-LOC, we can look at project level. With p2pen, we can look at package level, small level, class level, method level. But it also summarizes things in a really, really interesting way. And there's two famous graphs that nobody understands. This is one of them. It's actually really simple. Instability, the y-axis, instability is defined as the number of dependencies. Or I'm sorry, the ratio of external dependencies to internal dependencies. So each one of these dots are a package. So if you use dot blocks, the act package annotation, that's what each one of those bubbles is a unique package. So what it does is it goes through and it looks at the dependencies of each class and says, these are dependencies within the package and these are dependencies without. So a instability of 1.0 means we don't depend on anything inside, but we depend on everything outside. And an instability of 0 means everything we depend upon is local to our package. So it's just a relation of how durable that package is to external changes. And the bottom one, abstraction, is the ratio of interfaces and abstract classes to concrete classes. So a purely abstract package, the 1.0 over here, would be 100% interfaces, and 0 would be 100% concrete classes. So what does it really mean? Well, it's a quick way of looking and kind of getting an idea of whether a package contains a lot of concrete code or not a lot of concrete code. Does it contain a lot of internal dependencies or the dependencies intertwined? It's not a chart that you're going to look to for a lot of information, but it's a handy chart to look at to kind of get an idea of what packages touch everything and what packages are pretty local. The other chart that it gives us is this guy, this little pyramid. This pyramid is awesome because this gives us almost everything that PHP-LOC gave us in one quick little insight. So you have a little acronym and the value. So NOM is number of methods. So this particular chart is saying 578 methods. Lines of code, 6,528. Now this green number between the two is lines of code divided by number of methods. So there's, on average, 11.29 lines of code per method. And this entire chart is built up that way. So you have cyclomatic complexity, you have lines of code, number of methods, number of classes, and number of packages. And you can look at the ratio to see how big each component is in relation to the one underneath it. So that's the left half. And that's really just PHP-LOC all over again. Now the right half is really kind of cool. Fan out is the number of calls to other classes outside of the package. Calls is the number of calls in general. So fan out, this number right here, this 0.406 means 40% of the all method calls in this code base reference a separate package from the class that it's in. Again, it paints a picture. It tells us that our classes tend to be a little bit more spread out. Our packages tend to be a little bit more independent, or interdependent, I'm sorry. The lower that number, the more vertical our code base is, meaning each package is independent. And then the top two relate to hierarchy, so class hierarchy. And C is the average number of derived classes, tells us how much we're using inheritance, meaning how many classes extend from another class. And AHH is the average hierarchy height. So if you have 2 parents, 3 parents, 4 parents, 7 parents, 42 parents, these numbers. So really what we're looking at is a quick snapshot. Again, just like PHP-LOC, just in a more graphical format. And there are defined limits to when these are green, when they're gray, and when they're red. So, There's one more tool I'd like to talk about, which is PHP Mess Detector, which, like it sounds, detects messy code. Also bimanual, a German. Basically what this is it's a rule engine. So you have a series of rules. You have code size rules and code complexity rules. You have design rules and naming rules, and you can conditionally choose what rules you want your code to follow. So we can say, I don't want GoTo to be used anywhere in my code base. PHP LOC or PHP will go through your entire code base and find instances of GoTo and do two things. One, it'll log it and give you an XML file of all the violations. But number two, it will return an error code on the command line. See how this is useful? Anyone get an idea? What are we trying to do here? What is this really useful for? I heard Jenkins. There's an even better use, which is a pre-commit hook, or if you're using Git, a accept hook. If you run PHPMD on a pre-accept hook or a pre-commit hook, depending on whether you're using SVN or Git, you can prevent these codes from ever getting into your repository that breaks these rules. So we can say, if it has GoTo, fail 100% of the time. If one of your developers tries to push code that has GoTo in it, it will reject it from the commit level. And they will have to go back and fix it. It won't even allow it to get in the system. This is pretty powerful. You can set complexity guidelines. You can set how many lines of code do we want in each method. You can even set this thing up for naming to prevent short variable names unless they're IJK. This is pretty cool, right? So, by themselves, these tools are kind of useful, right? I hope you guys can see that. But over time, when we aggregate these tools, they're freaking awesome. So Jenkins PHP is a PHP template for Jenkins. And one of the things it includes are these nice pretty graphs. So it gives us our p-depend, or two p-depend graphs, but it also graphs over time some of those other metrics. And it does a whole lot more graphing. It graphs cyclomatic complexity. Basically, everything PHP LOC gives you, it can graph over time. So commit by commit, you can watch, are we getting better or are we getting worse? Pretty cool. But let's have some fun. Let's look at real code base. This is Drupal 8, the Drupal 8 branch as of May of this year. We started way back, or they started, I should say, I'm not part of the project. They started way back in March of 2011. They forked and they deleted a bunch of code. So they started out with about 10,000 lines of code. And by May of this year, they had about 180,000 lines of code. In about the span of a year, they went from 10,000 lines of code to 180,000 lines of code. That's pretty significant, right? So the way I generated this graph was I wrote a shell script that ran PHP LOC. I took the output, stuck it in a CSV file, and then ran git checkout head bracket 10. So basically, I rolled it back 10 commits, and I ran PHP LOC again. And I rolled it back 10 commits, and I ran PHP LOC again. So now I have metrics, PHP metrics, the entire lifetime of the code base on every 10th commit. So what we can do is we can look at things like the number of classes over time. And this is a logarithmic graph, and we start with about 6 classes in July of 2011, and we wind up with about 2,000 classes in May. So basically what these last two graphs have told us is the gigantic explosion of development effort. So what happened with complexity? Well, when we average complexity per method, we start off pretty high in the 3.5, and we finish just above 2. The average trend is downward. Yes, there's individual spikes which pump up, but it bumps up and then it comes back down. This is awesome. Cyclomatic complexity per line paints a similar story. We get really complex, and then it drops. And over time, you can see as development happens, it bumps up and down, but the overall trend is definitely significantly downward. And when we stack these graphs together, we paint this really pretty picture of ridiculously fast-paced development, but complexity gets lower. This is awesome. This is what we define as success. So I told you that I would tell you a story about Sebastian Berger. The first time I did this talk, I talked about him and I showed all this pretty stuff and everyone would nod. I posted the slides and YouTube went on literally after I got off the stage. It was live on YouTube. I went to bed that night. It was in Portland. I went to bed that night. I woke up in the morning and I had about 5 to 10 emails from GitHub. I'm like, why is GitHub emailing? And I look down at the email and I see commits from PHP-LOC by Sebastian Berger. He saw the video, he saw the slides, and implemented this functionality in PHP-LOC overnight. By the time I woke up after the talk, this is in PHP-LOC. So if you have a recent version of PHP-LOC, you can go into a git checkout and you add --git repository, and it will generate these files for you. So that's Drupal. What happens if we run this on other projects? Well, we can start to compare projects. So let's compare Drupal, Symfony 2, and WordPress. WordPress is this red bar on top. Drupal is the blue line, and Symfony is the yellow line. No, Drupal and Symfony, over time, are getting simpler. Yes, there's individual bumps where it gets a little bit more complex, but over time, things are being refactored, things are being simplified. WordPress? Yeah, over time, it's a decidedly upward trend. This is a problem. Anyone see that this is not a problem? Anyone think this is good? Okay. So, I'd like to show you something interesting. Live demo time. And as we all know, live demos can be fun. So, I took and I ran this on a whole bunch of projects. I ran it on, let's see, Cake PHP, Drupal 8, Symfony, WordPress, CodeIgniter, PHPBB, Joomla, Zen Framework 2, and Node.js. And I extracted all of these different tools. In Node.js, I had to fake a little bit because the tool PHP-LOC obviously would not work on it, and I had to find a JavaScript alternative, but we got most of the same numbers. And every single one of those fields that PHP-LOC gives us, we can see on the left-hand side of the screen here, the number of abstract classes, the number of anonymous functions, the average class length, the average method length, the number of class constants, the number of classes, etc. We can now graph. So, let's take a look at the average method length per project. That's what this graph here is telling us. So I imported all of that data into Splunk. Anyone here know Splunk? Oh, most people don't know Splunk. So I'm going to do Splunk a favor right now. I'm going to print them pretty good for you. Splunk is an awesome log analyzer tool. So what it really allows you to do is import a whole bunch of different disparate logs and correlate the data and display one search interface. So I imported all of those log files from all those different projects into Splunk, and now I can graph it. So this graph here shows us the average method length over time for each project. So PHPBB starts off with the longest average method length with 60, but over time it goes down. Pretty cool, right? Zen Framework 2, uninteresting, basically level. WordPress, basically level, but kind of goes up a little bit. Symfony, basically level. Node is by far the lowest and basically level. Joomla, Drupal, CodeIgniter is basically level as well, and Cake. So I wanted to show this one just to kind of demonstrate what this tool is capable of. But let's go a little bit further. Let's look at something a little bit more interesting. Nope, not that one. That one. Let's take a look at, for example, just to show we can do some interesting calculations. Let's look at the ratio between comment lines of code and non-comment lines of code. Why? Why not? So, mostly uninteresting, everything looks pretty level, except, wait a minute, at one point Drupal had roughly 1.7 times the number of comments as it did the number of lines of code. That's weird. I don't know what it means, but we can look at other things. Node.js, same thing. We had a big spike of comments, up to 1.5 comments for every line of code, but then it came back to normal. The whole point of this, and the reason why I want to show you this, is not that this gives us conclusions. It doesn't. This gives us questions. We can look at these trends, we can look at what happens over time, and we can start to figure out what questions we need to ask of our tools. Yes? Yes. It's anything that is a comment token. So dot comments and commented code as well. Anyone have any queries they want me to run? We have a whole bunch of fields, we have a few minutes. Yeah?
Number of global variables.
It doesn't do global variables. That would be a good one though. We could do number of constants, average over time. Come on. Let's try that. And then I need to so number of constants. Wait, what? Zen Framework 2 had 3,800 constants. I'm sorry, 3,800 constants. And that doesn't include class constants. That's just global constants. Everything else is basically level, but there was a major refactor in August 1st of 2012 that cut that down. Again, this doesn't give us answers, it gives us questions. It lets us look at over time how do things relate. Anything else anyone wants to look at? We have some luck here, anybody? No? Okay. So, there's one more thing I want to leave you with. Has anyone seen this comic? Yeah. If you can't see in the back, I'll summarize it really quickly. We have this flow chart on how to write good code, and then we have the good code endpoint, and they're not connected. Basically implying we don't know how to write good code. And I really want to drill that home. These tools do not tell us what code is good and what code is bad. It doesn't tell us what code is effective and what's not effective. What it does is it tells us over time, are we getting better or are we getting worse, based on complexity alone. What's going to tell us whether code is good or not is, does the code deliver business value? That is number one prime importance. If code does not deliver business value, it is bad code. I don't care how pretty it looks, I don't care how many unit tests it has. If it doesn't deliver business value, it is poor code. I think that's the number one thing that we need to be realistic about. Good versus good enough. So keep that in mind. And any questions? Yes?
Use all photos of your children.
Yes. I have many, 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 many different children. No. Go on. Any other questions? Come on, don't make me call and point at people. I will. I'll do it. No? Thank you.